Thank you very much, Prachi, for that introduction. Um, very good morning again, gentlemen. Uh, I think we've just to continue with what I was talking about. It's very interesting to have this power pack panel here. I think we have representations from multiple angles. We've got OEMs, software companies, tier one suppliers. I think it's going to be very interesting to hear from you, gentlemen, how you see some of the opportunities in the entire SDV ecosystem evolving. Uh, Bhupesh, I want to start with you first. Uh, so interestingly, Bhupesh is part of what's called as a software factory at RNTBCI or at Renault Nissan Technology and Business Center in India. So very interesting, terminology there to call it as a software factory because we haven't seen that in India so far. I have a bit of a history with RNTBCI as well. I used to work with Nissan India, and I've had the opportunity of visiting RNTBCI practically every week to understand how Renault Nissan alliance has been leveraging their technical and business center in India to provide engineering solutions not only for Renault and Nissan, of course, but also to look at other global OEM customers as well. Now, Bhupesh, Renault and Valeo have signed a partnership recently, right?
Yes.
For developing electronic components, through their high performance computer, and also to contribute to software development. Now, one of the key aims of this partnership, between Renault and Valeo, which is also a French tier one company, is to reduce, let's say, product development times for electrical architecture platforms. And how do you see this partnership with Valeo evolving, number one? And how do you see the software factory at RNTBCI becoming a global beacon for engineering and software solutions? What are your thoughts there?
So thank you, Kaushik. Let me first start with the question on the software factory that you asked. So all of us here, when we hear the word factory, we know that there is definite set of process, there is definite set of sequence, and there is definite set of rules that has to be followed. Yeah. There is a line, there is a responsibility clearly defined. And at Renault and Nissan, when we are still in the alliance mode, and when we started doing the software development in-house somewhere around 8 to 10 years back, we felt that we cannot be unorganized. Yeah. We have to be organized because there are definite specific needs of Renault, the way legacy that has been doing, and there is definite specific way of Nissan. So we thought, why not build a similar process, similar methods, similar tools to develop it commonly so that we can reduce the time to market and also avoid the duplication of the effort on this. And that's how this software factory world was jumped in. And initially, all the engineering community felt that software factory is not a good word for software. But we feel that if you have the right process, method, tools, and you follow the processes, you can get the direction, or you can get the outcome which is in a correct way and easily with time to market. What our expectation on that? Secondly, if you are avoiding these duplications, then you can also save the time and save the cost as well. And you know that these are the two most important factors that any OEMs are looking at. Coming to your partnership related thing, of course, Value is recently we have announced on some specific functions to be done by them. Renault, basically, you know that sometime back in 2017, till 2017, Renault was not really focused as a software primary company. They were more OEM integrating the systems. But we felt the need that there is a strong need of going towards a tech company or a software company. And here is where Renault integrated the Intel company, which is Software Renault Labs earlier. And this began our journey towards a software thing. And one of the key mantras that we followed at that time, let's do the thing which is done at a right skill and right people. And this led us to the further partnerships with Google, with Qualcomm, and Valeo, and also KPIT. About Valeo, there are some specific tasks or specific assignments that we want them to do. And of course, you know that in the multi-layered architecture of SDV, we have the starting from the very hardware electronics, the car OS or the then the application software, and further the cloud services. So at each of these responsibilities, as the other panelists in the first thing, not one person or one player can do everything. So this is the objective of this partnership, and we feel that we are in a right place now with all the players in the right place and the right Rasik at every level.
Thank you very much for that, Bhupesh. I think just to continue on that point where you said the idea of factory originated from the concept that you've got a process, right? You've got lines, you've got steps, one after the other. So just to go back to the point I made earlier as well, do you see RNTBCI also offering services to other global OEMs, or do you think Renault and Nissan will still be primary consumers? But from your perspective, do you see, let's say, other German competing OEMs also leveraging the services of RNTBCI going forward?
Sure. You know that basically our Renault Nissan strategy as of now is basically to go an open system ecosystem basically. And the main target is basically the enriching the user experience.
Correct.
And in this case, the as we see that it is the beginning of this transformation phase. It's what I would say on this beginning of transformation stage. Many models, many business models will evolve. One of the objective for us is also the being able to sell our products or platforms or the apps to other OEMs. I see that these models will evolve more in future, and as we see that the what is really shaping up, which is getting more concretized, there could be some opportunities like that. But at this point of time, we wait how the transformation is leading to which direction.
Understood. I think that's a fairly good answer. Srinivas, I want to come to you now. I was actually reading an article Deepanshu had published, of an interview of yours in the recent times, where you spoke about digital enablement for SDVs, connected digital products, and let's say BlueBinaries core capabilities. You have been known in the industry as a Mahindra veteran, and from your perspective, how do you see BlueBinaries becoming an enabler for OEMs and in helping them develop agile software-defined platforms? So, how do you see the role of BlueBinaries evolving in the entire SDV ecosystem?
Thank you for that, Kaushik. See, at BlueBinaries, with regards to SDV, with regards to software-defined vehicles, what we do is fundamentally offering the architecture. We start the journey from E&D architecture. So we are having all the requisite capabilities of building the right architecture, which is supposed to be modular, scalable, and importantly, to have that bandwidth of network for the sake of communication between these high-performing HPCs, and also looking at the functionality and features that are required by the OEM, putting it in a manner. Finally, essentially, this E&D architecture should evolve into SDV. I mean, that's the journey that we are trying to put it, and it could be in a phased manner, or right up front we will be providing how the SDV structure should be. But our journey is starting from E&D architecture. That's where we are contributing.
You touched upon a very important point on modularity, right? I think that is something we just very briefly touched upon, since this morning. So tell us a little bit more on that. Obviously, when we talk of modularity, at many levels, we are talking about some form of commoditization as well, especially from an architecture level. So do you see modularity also playing a key role in the entire SDV ecosystem value chain? What are your thoughts on modularity there?
See, definitely modularity is going to play a role. Uh, Overall, when you have fundamentally, when you look at the OEM's journey, everybody is coming up with lots of variants, lot of models from a base architecture, a standard architecture. Why we need this modularity is to take care of, and again, end of the day, to take care of so-called matrix of variant matrix, model matrix. At the same time, the cost optimization by virtue of the overall cost, total cost acquisition or cost of operation. Looking at that, modularity is extremely important in order to derive the right set of functions and features required for that particular variant, and how do we do that at the end of the line by virtue of flashing, etc. So we are giving very significant importance for that piece, again coming from the cost optimization as well as from the manufacturing standpoint.
So adding layers beyond that modularity
Yeah.
standpoint is going to be key. Understood. Thanks. So Vikrant, Bhangay, I want to come to you now from FEV's perspective, right? So I have a bit of a history with FEV. I did my master thesis at FEV under Professor Bishinger 22 years ago. So I have seen how FEV has evolved 2.5 decades ago from being a hardcore engine powertrain technologies service provider to today being a big player in the entire SDV ecosystem. Interestingly, for people who don't know, FEV has partnered with Wipro for developing solutions for next generation SDVs, right? They have created what's called as the innovation lab, where the focus is all about looking at integrated system features, scalable architecture, serviceable, service-oriented software, developing E&E architectures, for global and Indian markets. So, Vikrant, tell us how the journey of FEV has been from being a powertrain engineering services provider to being a significant player today in the entire SDV ecosystem.
Thanks, Kaushik. And nice to know that you are connected with FEV from last 20 years. So I think the question about being a powertrain driven company and now completely shift into the SDV. See, I will tell you, a lot of people talk about SDV, but there are challenges in the SDV which needs to be addressed now. The challenges are, suppose I have a traditional functionality done in a monolithic architecture, firmware-based system, a small ECU, which are actually doing the things in isolation. Okay, so we have the IPs created traditionally for all the subsystems, which is mainly a vehicle.
Correct.
And now what we are talking in the SDV world, it is plus than the vehicle. It's a lot more than just the vehicle operations. So we as an FEV understands how to split the functionality of existing architecture into the modern architecture, which is an SDV. So what is the most challenging thing is, how do I split in the new EE architecture the things, let's say, into the zonal controller and central compute? Which part should I split into two? So we being so if you are a SLD compliant, you have to do the things at the edge itself. You cannot go to the central compute. Suppose the performance you need is less than 5 milliseconds, you have to do there and there itself. You cannot say that I go from edge to the central compute. So there are parameters where you really need a traditional knowledge of a vehicle, and then how do you split this functionality into the modern EE architecture and the SDV way. So when I am saying SDV way, you should be quickly able to take the old model, divide the old model and monolithic architecture into the service-oriented architecture, and bring the functional safety element, which was earlier in isolation done in one ECU. Now it is spread across your, let's say, zonal, central, and the leaf nodes. So SDV actually knows the vehicle in and out. So if you take any program right from vehicle design to the SDV now, so we know how every ecosystem works. And in the morning, Anand talked about the organization has to be aligned in such a way that you address all the subsystems taking a thought of everything. You cannot develop an E in isolation. You cannot think about safety in isolation. You cannot think about software in isolation. So your topic for today, when you talked about, so if I do system architecture and safety, I have to think about E. And when I design an E, I have to think about safety and system architecture. So now FEV understands the vehicle, all the modern technologies and the SDV platform that we have developed, and we are addressing exactly this point. How do you actually create the architecture which addresses not just today's need, but the future needs, and you don't need to actually change the software if you change the hardware. So those things are important.
So interesting point you made on the decision making at the zonal level, right? To use a very old automotive manufacturing terminology, the turnaround time, right? So you are deciding, depending on what the application is, and based on that, making a choice whether the decision has to be done on the cloud or on board edge, as we call it. Now tell me, isn't that driven by the OEM strategy? Because every OEM, has a different positioning of their, let's say, brand and vehicle in the entire market. I mean, classic example, Volvo is defined around safety, right? A BMW is defined around performance or driving experience. So who decides whether a particular decision making has to be done on board or on the cloud? Is it you or the OEM decides it?
See, I will tell you, if you talk about some of the European OEMs, they actually taken the control of architecture, let's say 10 years back.
Right.
And the emerging market OEMs now from last 3-4 years want to take that some control with them. So the decision to where to execute, right, and where the software component should go, as a product backlog, OEM decides the feature. But in the mature market, the things to some level OEM defines. But to a bigger part of the world, we as a software company and we as a company who understand this, right, should actually design the architecture and give the perspective of how the performance things, the bandwidth things, and the compute requirements can be fulfilled. So we need to support OEM to take that decision, though the basic requirement comes from OEM. But as I said, there are two worlds. Right. In some of the mature market, the OEM comes with the architecture, and majority of the OEMs we have to discuss and finalize.
Understood. Thank you very much for that, Vikrant. So Ashok, I want to come to you now. Now ZF Group has partnered with KPIT, right, to develop open and scalable middleware platforms and solutions. So you've created this independent company called Qorix, if I'm pronouncing it correctly, right? QORIX, to develop and distribute open and scalable middleware architecture, right? So now, obviously, KPIT in India has established a great brand name from the software development side, engineering services side, and so on. So how do you see the role of this newly formed, not very new, I must say, an independent company, Qorix, that is going to work with the OEMs to help develop, open source platforms where anybody from the outside can bring in their solutions and, use and leverage this platform. So how do you see the role of, an independent company like Qorix evolving in the SDV ecosystem?
Thanks, Kaushik, for the question. Qorix is the right pronunciation. Yeah. I think it's a best of both. This collaboration represents. Let me put that, first start with the challenge of the SDV, and then I saw the advantage. Today we talked about the software defined vehicle, and definitely it brings a lot of flexibility, freedom, and we all want personalization, customization, but it basically contradicts the vehicle behavior. The vehicle behavior is supposed to be predictable. When you apply a brake, the vehicle should deaccelerate, controlled, right? Today morning we heard about the examples about the smartphone and things. We all have a smartphone. Some might have two smartphones. Now sometime you might have opened an app on the smartphone, and the app would have told you update is in progress. It might have annoyed you a bit. You would have again opened it, and app might have worked for you. Imagine a case, early morning you start for your office, then you apply a brake, and dashboard you say sorry, update is in progress. It cannot happen, right? That's a bigger challenge the SDV or any vehicle architecture need to deal. And there comes the specialization of ZF, that our legacy of the system, component, EE architecture, that brings the predictability and we manage. However, we understand the mega trend of the SDV, and we have to increase the flexibility with the predictability. And there comes the ZF middleware, basically, where it has the basic, the AC level, the vehicle functionality, and also due to modular and scalable architecture, and also enables the cloud so that you can have all level of, let's say, autonomy, level of freedom. And that's what this JV meant, or collaboration meant for, to have the flexibility with predictability.
Interesting point you made. So essentially what you're saying is that the hardware is always going to offer that fallback option, right? When the software updates are happening, just so that there is no discontinuity in the operating behavior or in the user behavior, right? So that fallback option is what the hardware and middleware is going to guarantee, even though it is a software defined vehicle. Am I right in interpreting that way?
It's both, because now if you talk about, we have gone a way ahead than the fallback. It's now fault tolerant. There's no more fail safe, right? We are talking about the fault tolerant system, yeah, where your primary steering fails, but still you're able to steer the vehicle, right? That's a fault tolerant system we are talking about. Coming to the, if you look at ZF middleware, it basically provides the encapsulation between the hardware and the software.
Right.
So hardware definitely performs all the aspect of the vehicle predictability and the vehicle architecture, architecture. You talk about the system components, we can talk about it. What it does, basically, it encapsulates the software from the hardware, and that provides the freedom. Actually, you can have the vehicle functions, and the vehicle functions can be deployed in the vehicle, or it can also deployed using a digital platform on the cloud services. So that's what it basically provides you.
So does that mean Corix as an independent company will have the flexibility to partner or operate or work with other independent software companies or any companies that want to leverage the open source architecture to bring in services?
Yeah, I mean, today many panelists talked about the new business model, new working model.
Yeah.
I think it's evolving. It's too early to predict how. Nobody has a crystal ball, right? Today we do not know how the SDV or the entire ecosystem will evolve. But one thing is guaranteed: the trend says more collaborative. Yeah, so it's not happen that you provide the services and solutions for one organization. You basically provide the services and solutions of entire mankind. Now the collaboration model, business model, working model depends on a lot of revenue streams, a lot of IP protections, data. So I would not be able to answer exactly how the model will end, but definitely it will not be a kind of close collaboration. It will be more open collaboration, more open innovative ecosystem.
Got it. Understood. Thank you very much for that. So Kapil, I want to come to you now. Again, if you see the theme of all my discussion points this morning, it's all revolving around partnership and collaboration, right? Now, ETAS has partnered with Red Hat, right? You must have all heard of Red Hat as the company that was famous for Linux or whatever you may call it, right? Operating system. So now ETAS has partnered with Red Hat for connected vehicles, autonomous driving, and SDVs, right? Now, obviously, while ETAS brings in your cloud-based operation services, end-to-end engineering, Red Hat brings in software capabilities, right? That's been their strength. So how do you see the role of, let's say, pure play software companies like Red Hat, for example, who probably have nothing to do with automotive technologies, from the traditional sense, right? How do you see pure play software companies becoming a part of the mobility ecosystem as we see increased levels of personalization and especially features on demand, right? So when we talk about, I think, Dr. Sahu also mentioned about features on demand. So how do you see the role of a software company in the features on demand ecosystem?
Yeah. So I'll give you a background first based on the discussion what we had so far. So today we are talking about the bill of material in the vehicle, right? So, and we also discussed that the software contribution to the vehicle is becoming more and more.
Yeah.
You mentioned 60%, but more or less, I think that's a global figure. But for India also, I see that the number is increasing. Even if it is not 60%, at least we will be reaching to 30-35% in India by 2030. Having said that, this also opens up two moot points. That if the contribution of software is increasing, that means we also need to see the most of the innovation will also happen with software.
Correct.
And the cost implications of the software would be higher uh, going in the future, right? So considering these 2 points, I think the strategy for any OEM would be to have a better control on the software. Because to leverage both the topics, right?
Right.
So in order to leverage this, to have a better control, there are two options what I see. Of course, there are more details to that. One is either do you go with the ownership model, or you go with a partnership model, and these can be distributed as well. Now, coming to the middleware part, what the others also talked about. So I think with the software, if you look at the overall architecture, middleware plays a vital role there. Of course, applications will definitely remain with OEMs, which are more or less dependent on tier 1 as of today, but that direction is already, they are already going in that direction. So applications will go to OEM. The middleware, there will be different software stacks which will be provided by various companies, and this is we are going to call it as SBOM, which is the software bill of material. And the OEMs will take a choice or pick the right set of partners basis on their supports, quality, efficiency, all those aspects. And then this bill of material will slowly shift to the SBOM, and then of course the hardware bill of material. So having said that, now the disintegration of the software and the hardware is definitely it has to happen. There is no going back from there. And this ownership of OEM will decide the strategies also. Also in the hardware side, the E&D architecture, how we want to disintegrate or how do I really need to move into a central compute environment or a domain distributed architecture.
So that's an interesting point you make there, Kapil. So you're saying that the ownership still primarily will be retained by the OEMs. But if you look at some of the new age skateboard architecture companies, the likes of Canoe, for example, right? They're completely going the way of partnership model, right? Of course, they're not an OEM to begin with, right? That's a completely different angle that they are taking. So in such cases where we see new companies offering skateboard architectures, modular architectures, where it is completely on the partnership platform, how do you see the ownership versus partnership ecosystem evolving?
Yeah. So, as ETAS, we are being part of Bosch Group, and earlier ETAS was more of a hardware company, slowly shifting itself into a software company. Most of the 80% of our portfolio is now software, which was hardware predominantly. So when we talk about the partnership, so we see as a company, we playing more role in terms of the consultancy,
right?
The skill development. And just to tell you, one of the strategies which is coming from ETAS is we have also formed one vertical which is called the E2E, which is called end-to-end. Because today, if we see SDV, we have a lot of things to be addressed. But who is capable enough to actually stitch all these nodes together and come out with the final solution? Right. And it's a very complex environment. That's true. I mean, SDV is not a state. I would say it's a journey. Yeah. It is actually an innovation, which will continue. So we as company, being the partner to the OEMs or the tier ones, can address these challenges and come up with selecting the right SBOM, I would say, and also the skill development or the finding out the right ownership sets at the OEM.
Interesting. I like the point when you said SDV it's a journey. It's not an end state. So clearly, it's an ever evolving ecosystem. So Sachin, I want to come to you now. I want to talk to you about a completely new angle that we haven't touched upon today, which is cybersecurity. Right. I mean, from BlackBerry QNX perspective, right? Your portfolio includes software, certicoms, elliptical curve cryptography. That's a bit of a mouthful for me as well. And especially looking at over-the-air updates, right? That provides complete end-to-end, management capability for embedded software, right? So from your perspective, how do you see the entire cybersecurity angle evolving? Because obviously, the moment we talk about SDVs, you've got multiple players coming in open source architecture, so there is a little there's a little bit of a threat there, vulnerability there, in terms of how the software defined vehicles are structured. So how do you see the entire cyber security challenge evolving, and where do you see some of the solutions in terms of what the OEMs should keep in mind, or even the software developers or tier one companies should look out for in the near future?
Uh, it's a nice question actually. Cybersecurity, software-defined vehicles, they are interconnected.
Yeah.
So being from BlackBerry QNX, so the solution will never come from the top. It should be come from the bottom. When I am saying bottom, I am talking about the operating system. I'm
Right.
talking about the firmware. I'm
Right.
talking about the middleware. So when we are considering these low level component, the operating system, the firmware, they should have design for safety and security. Then you will able to address security challenges as well as safety challenges. So right from the operating system approach, as Vikrant said, it's a modular and the microkernel. So design should be modular, design should be microkernel based. So idea is that every module should run in their own protected memory space, so that if anything wrong happen in one module, that will not affect others. Same manner you will able to address, you will able to minimize the attack surface. So we are addressing these issues right from the operating system layer. So I believe the OEM and the tier ones, when they are choosing these components, they will consider and they are considering the modular architecture. They are considering the microkernel approach, and they are addressing safety and security right in the design.
That's a very good point you make, Sachin, and I completely agree with you on that. That design should be part of safety should be part of the design ground up. One of the challenges that I've always seen and discussed with various stakeholders is, especially when it comes to cybersecurity and virtual simulation, is fringe cases, right? There will always be certain fringe cases which we haven't considered, which we realize later after they occur. So how do you compensate, when you talk about cybersecurity, for really, really remote fringe cases, which probably some of us haven't thought of, but later on could pose significant challenges? How do you compensate for those?
Actually, it's a long answer question. So being a techie, what I can say that addressing those issues are at, you can address them at multiple level.
Mhm.
Every hacker love buffer overflow. So if we are able to addressing buffer overflow right into the C library, right into the operating system, if I able to the protect threats,
Right.
thread stack overflow and all, then I will able to address these challenges which are supposed to come. So technically, if you are if we are able to run every module in their own protected memory space, and if I am applying multiple security p- policies and I am controlling them, I will able to address it. And plus we have everybody, even OEM, everybody should have the response mechanism.
Right.
Whenever a vulnerability is found, then there should be a dedicated team who will immediately work on that, and they will fix that issue and they will provide updates. So in a nutshell, what I want to say that if we are addressing these issues right in the design, we will definitely able to address them at top level.
Interesting. That definitely is heartening to hear. So in the interest of time, so I want to quickly ask Bhupesh one point, and before we open up for questions from the audience. So Bhupesh, we exchanged a couple of emails, over the past 2 days, especially on the VAS and BAS ecosystem, right? In the automotive ecosystem, VAS has always stood for vehicle as a service, and BAS has stood for battery as a service, right? In our electrification ecosystem, we are seeing new asset light business models. that is decoupling the cost of battery to make electric vehicle acquisition a lot more affordable. And that is where battery as a service is coming into the picture, and vehicle as a service as well for fleet operators too. So interestingly, you said, can we look at it as virtualization as a service and backend as a service? But tell us a little bit about that. How do you see in the entire software defined vehicle ecosystem, how do you see virtualization as a service offering opportunities for new players and also for OEMs to look at these new monetization opportunities, and backend as a service? So is that a new opportunity for a software company to become a BaaS player, which is a backend as a service player, to OEMs and tier 1 suppliers? What are your thoughts on that?
Yeah, when I received this mail from you, and yeah, of course, it's very well known fact that vehicle as a service and a battery as a service. I also thought of a different perspective from that point, that okay, Ola, Uber, and even today they are doing as vehicle as a service or something. Shared service is already there. But what is so specific about SDV on that? And you know that SDV, one of the concept of SDV is basically to reduce the development time by half something. So one of the solution for this is virtualization, because you need not really wait for the hardware to be ready to test. All of us are well familiar with the DevOps concept. We know that it is really needed to be done as fast and as in an agile way to do. But can you really match the speed of development when you do the validation? I think this is a big challenge for the operations or the validators. So what is the solution here? Solution is to virtualize, to be able to do the moment you develop. What software you are developing, it should be able to test within your sprint cycle or the whatever 4 weeks, 6 weeks, what you have defined. Of course, it requires a lot of efficient tools, or the what I would say, the virtualized environment should be as close as possible to the hardware thing. But virtualization has many advantages, not in terms of the time to market, but also you save a lot of cost. Because you really avoid the need of the hardware costly items, and once you develop this virtualized environment for you, you can really avoid and reuse this multiple times. This is one. The second, virtualization needs specific skills which may not be there with the automotive engineers as such, because you need some really ISIT or scripting language, or the tools that are really required to exactly replicate the specific automotive application. Also, you need to get a system as a knowledge, because you cannot really virtualize everything without knowing the system. Another aspect of virtualization, what I would say is, you have multiple environment. Like if you are trying to test HMI or cluster in a virtual environment, but there are a lot of interfaces with either cloud services or ADAS or body or chassis. And when you need this entire system to be bigger, probably you also need some sort of very good understanding of the architecture behind both at the system as well as the software. And you need a lot of interaction with various stakeholders across. So what we felt that virtualization, if we can dedicate to some people or some mind of the people, some who has that mindset to encompass all these different needs of validation, why not do it? And model-based system engineering or model-based software development, because you have it in a computer in a digitized way, it can help you a lot. So this has got a huge potential to be offered as a service on this. On the back end as a service, basically that the OEM and the other software developers, they are focusing on their core activities of software development or application development. Backend as a service is taken as a probably the cloud services or something. What you need to send reminder, you need send to get some data. When you observe the data, you analyze it and all those. So I feel that this could be a dedicated department or dedicated team or dedicated partner to work on this as a thing without disturbing the main activities that you engage to do. So
Exactly.
that's how I try to spend some time with you on the backend as a service and virtualization as a
I think
service.
this is the realm of companies like MathWorks or even ETAS, to a significant extent. So maybe Kapil, your couple of points, your thoughts on virtualization as a service and
Sure.
backend as a service.
Yeah. So, just extending that point, yes, virtualization is a key element to be addressed, because if you want to innovate faster, you need to find out the efficient tools for that. So there are tools available in the market where you can do the virtualization of the ECUs or the control software.
Yep.
Then, not only looking at one particular ECU, we need to look at the complete ecosystem, right? The other system suppliers are there. So, as a part of preparation, I would say the RFQs which are floated to the tier ones,
Mhm.
that will become, virtualization will become as part of the specifications.
Right.
And that whole pipeline which will be developed for this innovation, right? The tier ones will be sending their, virtual ECUs to that pipeline so that they can be a system integration test possible. And that would be the real efficiency on the validation side, I'm saying. But yes, of course, there are other pipelines which also need to be addressed.
I think efficiency improvement is also one of the key aspects there. So thank you very much once again, gentlemen. So let's open it for questions from the audience. Please raise your hands, introduce yourselves, and you can address it to one or more panelists here. Any questions we have? Yeah, we've got one here.
Good afternoon, everyone. I'm Sagar from Saranj. One question to both Kapil and Mr. Bhupesh on the increasing the efficiency and the virtualization. From my perspective, if I take up specific issue, let's say infotainment issue, for example, I understand the virtualization is actually increasing the efficiency and reducing a lot of the man hour as well as the cost. But there are certain specific issues you cannot use everything, rely on the virtualization to make that happen. For example, let's consider you wanted to enable your cluster or the infotainment system with the voice assistance, or so those kind of features you cannot test because that has to be tested actually on the vehicle itself. So I just wanted to understand, and I also wanted to learn how you address this aspect, because there are certain aspects you have to done it actually on the hardware.
Yeah, let me go ahead on this. You are absolutely right that virtualization doesn't 100% fits the hardware in the loop validation, because there are many parameters, including the timing related response latency times, and also the what I would say the triggers that come from the real hardware environment. You cannot exactly replicate in the virtualized environment. The objective of virtualization should not be seen as the 100% compliance or meeting the hardware in the loop thing. You definitely will need the hardware in the loop or the system level testing on the vehicle or in the vehicle and whatever environment you do. So this cannot be replaced by virtualization. It will definitely be how to be done. But the advantage of virtualization is you have many functional issues which can easily be addressed, which you need not really wait till the end. And this is the biggest thing. Another thing in also virtualization is the functionality, and there are also some non-functional requirements that you probably cannot really detect on the hardware. And this is the value addition that virtualization can bring in. So we look at virtualization from this aspect. Definitely it cannot replace the hardware or the real system or the vehicle testing.
Essentially to accelerate, not to replace.
Exactly. It is to reduce. And we call it as most of you are aware, shift left strategy. So however you shift left, the more you shift, the better. And today, I think the hardware replacement 100% is not possible, but as close as possible to 100% if we can go, it will be the beneficial for everybody.
Yeah, more of front loading than
Exact. Yeah.
Yeah, so completely is already said it also. I would say the goal is not to do 100%, that's clear. How much is possible, that's important. But you should also look at not only the control software as a standalone, right? You should also look at the other intricacies and how it is connected to the rest of the bus. Okay, and there virtualization will play a vital role. So because you can't have a hill farm for the complete system, And there, the software, which is a minimal cost test solution, there you can definitely address most of the challenges.
And completely agree, like it will increase the efficiency on the testing side because it reduce the the dependency of the tier 1 manufacturing the ECUs. By that time, at least OEM can do that virtually. That I completely agree. Second question is for Mr. Vikrant. As you mentioned, FEV with Wipro, you have created the innovation lab. So one question on the connected cockpit display which you are mentioning, just wanted to understand what is actually the use case and what is the intention from FEV on that particular system.
So currently what we are displaying today is completely developed by FEV. So there is no role of Wipro in that.
Okay.
And intention is to actually, if you look at the demonstration that we have put outside, we are actually showing the different subsystems. Let's say today's, if you look at the vehicle, you have a body, chassis, then ADAS and cockpit. And what we are trying to show here is how do you partition the system? How do you distribute the things? How do you take the legacy model and convert that into service-oriented architecture from the signal-based architecture? So all the SDV elements which are currently very critical to understand how the SOA works in the different subsystem, that is what we are demonstrating. And one thing I just, because you asked previous question also on virtualization, and I have spent so many years in the cockpit. So see, we are talking about 3 virtualizations. One virtualization is to partition the system, like using a hypervisor and all.
Yeah.
The other is, I am an ECU, and I want the other ECUs to get virtualized to test my ECU. Okay. So because I cannot every time have all the ECUs around me when I am testing my ECU. The third thing is, how do I virtualize my own ECU itself? Okay. These are the 3 aspects of virtualization, and all 3 are being addressed right now to the 90% extent. And even in the cockpit, and especially the voice recognition part that you showed, only the hardware abstraction layer. And when you have a voice, the only mic and the speaker part is actually hardware dependent, and some of the acceleration part. All the business logic, middleware, HMI, and integration of subsystems are not dependent on hardware. So 90% of the functionality you should be able to develop, test through virtualization, and you don't really need a hardware right now for that. So it is proven, it is done even in the voice recognition.
Okay. And one for the curiosity that the connected cockpit system, are you only focusing on the commercial vehicle, looks like from the system, or you also have a plan for the passenger vehicles as well?
So this is what we are demonstrating is a more of capability. And somebody actually asked me such question that SDV is for commercial or passenger. Actually, SDV is for everyone. And people also interchangeably use the word SDV for zonal architecture. Let me say that SDV can be there without zonal architecture. SDV can be there with passenger, with commercial, the lowest end vehicle and the highest end vehicle. So the SDV is an approach to think about the future right now. I will just take one more minute to explain you. So few years back, when actually I bought my house, I just thought about having some modular kitchen and let's say a basic things and started using that. Then I realized I need one more parking because I am buying another vehicle. Then I realized that now I have more money, I can do 1, 3, 4 things. And then I started looking at my house. It was not organized. It was actually because I have done different things at different stages of my life. And then when I see, I found that it is messed up.
Yeah.
Today's OEM have not designed the E architecture by design. It has evolved. Kisi partner, competitor ne ek feature dala, I am putting that feature with the same E architecture. And then tomorrow somebody brings something me, I am just trying to adjust my bus width and adding one more feature. And if you look at the current E architecture, it is not by design. It has evolved because of addition of feature. एक नया feature लाया, एक नया ECU डाला, एक नया feature डाला. I mean, I'm just giving an example. But now the time has come. You have to think from bottom up that I design a system in such a way that for next 10 years, even if I have a lowest end vehicle, highest end vehicle, commercial or passenger, same software architecture should actually cater all the needs. That's how we are looking at it.
Absolutely. I think the classic example that we see in the electric vehicle ecosystem is whether it is built electric or born electric, right? So that's a classic example you gave, that built is something that's been added over a period of time, whereas you haven't built, it was exactly. Exactly. Yeah. Very good. Any other questions?
Last question for Sachin.
I think you must give somebody else a chance as well. I think you've asked quite a few questions. Yes, you've got a question there.
Yeah, good afternoon, everyone. My name is Puran, and I'm from HL Mando. I have a question from Bhupesh and Sachin. Bhupesh has a perspective from OEM perspective, and Bhupesh has a like cyber security perspective. Because since in software-defined vehicles, now as you rightly said, like 60% of the BOM is about to be with software only. So in this context, like what about the certification trends? Like if we compare from in terms of European market and Indian market, so what are the different regulations which are about to come, or what are the different regulations which are already there in place for the cyber security or security point of view in the vehicle?
So, if I got your question, what are the regulations that are upcoming on the cyber security front, right?
Yeah, correct.
With respect to HMI.
Yeah.
To be very frank, I'm not a cyber security specialist or something, but yeah, these standards or the regulations are coming and they are evolving. And basically, what I would say, what we today are doing is analyzing the requirements that are coming from the cybersecurity, but the objective is very clear: to make and develop the software which is very robust. As Sachin mentioned some time back, that you have to design your system in a such a way that you have to think that any from anywhere any attack can come, and any probably the all components are fragile, but how you can make that robust. So what I would say on the regulations, there are various aspects that we are really studying today. It is early phase for us on the regulations and meeting, because we are not yet there at that point of time. However, I would say that we do have a lot of focus on developing the safe, agile, with a cybersecurity point of view from the verification validation strategies. Another thing, what I would say is, when we do test the HMI software or the point on the connectivity related thing, today we do partner with a lot of other partners from French, and they do help us in this aspect. In future, the what I would say ambition is to do it by ourselves or control ourselves, and this is work in progress at the moment.
Thank you very much.
Thank you.
I think in the interest of time, we must wrap this up. Dipanshu says no lunch for me if I don't finish it in the next minute. So thank you very much again, ladies and gentlemen. I think my panelists have been wonderful in terms of sharing their perspectives. So it's been a learning experience for me as well, as is always the case. So I must thank once again Mobility Outlook and Dipanshu for organizing this event that has been the talking point for many months now, and I'm sure it's going to be one of the keenly looked at areas in the near future as well. So thank you very much once again, and I hope you have a wonderful day ahead with the rest of the discussions and presentations. Thank you.